Hello everyone, welcome to our deep dive into Kaggle ecosystem spanning over 15 years of competitive artificial intelligence and machine learning. This notebook is designed to analyze billions of records of Meta Kaggle and Meta Kaggle code datasets to uncover hidden trends and forecast the future. Let's walk through the core components that made this analysis possible. Full disclosure, I'm only using a free tier of Kaggle, and I am only allowed to upload around 12 to 15 minutes in YouTube. So I'm gonna have to explain one section, and the similar structure is being followed for all the analysis. So let's dive deep into it. We are trying to address these key research questions: competitive evolution, community growth, technology trends, ecosystem dynamics, and future trajectory. We used a memory efficient chunked processing strategy to handle large dataset files. In a bit you'll see the size of each dataset files from MetaKaggle. So we needed to come up with a with a what do you call a solution to work around these large datasets to load the data without losing without losing the analysis over the span of 15 years. So the setup environment function, it just gives you just gives you the it's kind of like an organizer. It imports all essential Python libraries, and by running this once, you ensure that every part of your analysis has access to the right tools configured exactly as needed, making the rest of the notebook smooth and efficient. The section 2, this is the heart of this analysis. We defined a class called memory Kaggle data loader class. This custom class is built specifically to manage and optimize the loading of large Kaggle datasets. It's designed to prevent our system from running out of memory, since we are only using a free tier of Kaggle, and it has some key components. Optimize dtypes function. This method automatically scans our data frames and converts column types to the most efficient format. For instance, small numbers might be stored as integer 8 instead of integer 64, saving significant RAM. It's like decluttering our backpack to by packing more efficiently, so we can carry a lot more data without overloading our computer's memory. So the next function is load large CSV chunk. This is the function that we use for huge CSV files. Instead of trying to load an entire gigabyte file at once, it reads the data in small, manageable chunks. It can also filter data by specific years and even sample the data if only need a portion. It monitors our system's memory usage in real time, adjusting chunk sizes and combining data adaptively to stay within the safe limits. This method is crucial for handling datasets that are too large to fit into memory. That's enabling analysis on a truly massive information. So the data, and we have download datasets. This function is straightforward. We use Kaggle Hub library to download the MetaKaggle and MetaKaggle code datasets. It streamlines the process of acquiring the data, ensuring reproducibility and consistency without manual downloads. The next one, so as I mentioned before, you can see the true size of each and every files. Some of the files are even going over 15,000 megabytes. Yeah, so that's the point. We have created the class for loading efficiently. So let's move on to the Kaggle competition analytics pipeline. This part is all about understanding how Kaggle competitions have evolved over time, their trends, participation, and impact. And we have a lot of key components. This is the same similar structure we would be following for all the analysis. So the validate required columns checks and ensures your data has all the necessary columns before any analysis begins. And the load competition data, this specifically loads the competitions files using our memory efficient loader. It then adds crucial time-based features like year, month, and quarter from the competition start date. It also calculates derived metrics such as duration days, and the analyze temporal trends. It aggregates yearly statistics for competition counts, total prize money awarded, average number of competitors, and average competition duration. It also calculates year-over-year growth rates and identifies the most active months for the new competition. So they analyze price distribution. This function categorizes competitions based on the prize money into different categories like $1,000, $1,000 to $5,000, and so on. And analyze participation. This explores the relationship between maximum allowed team size and the overall number of participants. It also calculates the average and maximum number of submissions per competitor. This kind of gives an idea about the community engagement and the competitive intensity within the different competition formats. So the analyze evaluation methods is used to analyze the most frequently used metrics such as mean squared error, AUZ, and categorization accuracy across competitions over the years, and identify which metrics are going in popularity. So we have analyzed dataset characteristics. It analyzes the typical size of datasets. and analyze competition structure. This function looks at the adoption of Kaggle kernels and analyze hosts. This identifies top organizations or segments that host competitions and highlights the most generous sponsors based on the total prize money contributions. And we also have a create visualization function specifically for competitions. This kind of gives you a multi-panel dashboard displaying all key trends analyzed in this section. So I'll show you the output for all this when you run all this code here. You will see the 9,786 rows are loaded from competitions, and we have our temporal analysis, and the price analysis, participation analysis, evaluation method analysis, competition structure insights. And when you run the chart, and you'll see really pretty beautiful charts about all the competition insights that we have derived so far. This gives you an insight into the trends that is followed in competitions over the last decade and a half. And we print some key insights. So the next section is Kaggle user community analytics pipeline. So here we unravel the growth, engagement, and progression of Kaggle's vast user base. It's about understanding the people behind the algorithms. Similar to competition, we have data loading and preparation, growth metric calculation, interactive visualizations, and printing of key insights. I'll walk you through the final output about printing the statements and the graphs. Yeah, you can see over 1 million records, 1.2 million records have been loaded here, and we print the charts here, and you can see user growth by year, user distribution by region, monthly registration pattern, performance state distribution based on the users proficiency level. We mark them as contributor, expert, master, and grandmaster, and top 50 countries by user count, and India seems to be at the second position. Yeah, and enhanced growth analysis, annual registrations, we have a growth rate, etc. And moving on to the Kaggle kernel analysis here, uh, kernels, now often called notebooks, are where Kaggle users share their code, analysis, and models. This section dives deep into these computational environments. Similar to users, we also have the same data loading, metric computation, chart generation, and console level insights printing. I'll walk you through all this in the chart creation section. You will find a lot of insights in the kernels. And here I wanted to point out one thing. During our metrics, the data loader, we have a parameter called sample fraction, and as you could see, the kernel's data set have is about 3000 megabytes of data. And since we are only restricted to 30 GB RAM of the free tier in Kaggle, we only loaded about 0.5 out of 1. 0.5 means 50% of data. Out of 100%, we are only loading 50% of data of the kernel's database, kernel versions, and kernel's data set. And you could see in the output, we are loading about 7 million records, and based on that, we are analyzing the kernel growth, code complexity, acceleration usage, author analysis, popularity analysis, content analysis, language analysis, language trends, and Docker image analysis, fork analysis, and some printing the key insights. And you could see the same graphs for all those here. This gives you much more better insights about kernel's usage in Kaggle. And let's move on to Kaggle dataset analytics pipeline. So the Kaggle dataset analytics pipeline, datasets are raw materials for all data science, right? This section explores how datasets are created, shared, and consumed on Kaggle. So similar to users and competition, we just have a lot of data loading, and deriving some metrics, and printing of the key insights and visualizations as well. I'll walk you through the graphs and charts that we have printed and some key insights from this section. Yeah, you can see we are loaded about 500,000 records from datasets at CSV, and we are seeing dataset views, dataset downloads, kernels, ownership, medal distribution, dataset freshness about the creation and the updation, the average days between creation and updation of the datasets, dataset types versus engagement, yearly dataset trends, top 10 most viewed datasets, and we are also printing out the insights about annual dataset and growth. You'll also see some correlations about the datasets about monthly publication heat map, engagement score distribution, and the success factors and correlations of the datasets. And we also print some engagement metrics correlations map between these columns, and we are also printing some comprehensive key insights. The next is the Kaggle ecosystem correlation analysis. So here what we are trying to do is uh, so we are kind of gathering all the data metrics that we have derived in the above column. So this would have all the data sets metrics that we have derived above, and uses them to show you a comprehensive analysis over the name. So here you can see we are consuming competitions, new users, cumulative, kernels created, that all the metrics that we have derived in the previous cells, and we sort of creating a correlation heat map and year over year growth based on that as well. And let's the Kaggle code repository analysis. This this kind of implicit functions as a massive code repository. This section is about understanding the characteristics of the actual code being written and shared. And we are using Meta Kaggle code dataset file here. And this has a huge amount of data, and we are only sampling around about 13,000 files from all the datasets inside, all the data files inside. And based on that, we are deriving the insights from here. And the next one is the Kaggle ecosystem predictive insights. Here we are predicting based on the metrics that we have derived so far. We are predicting predicting the ecosystem up until the year 2030. I'll show you the graph so you'd be able to understand. Yeah, so we're doing the competition count, total prize money, new user forecast, kernel created forecast up until 2030. You can see we have a clear upward trend in all the charts. The next is the executive summary. Here we are just showing a summary about what are all the metrics that we have derived so far, and giving you a comprehensive printing statements about some of the important metrics about platform, competition, community, and some insights about what are the strategic recommendations that we can do. And we are just printing some generalized charts about each sections. So yeah, that's about it for the Kaggle meta-analysis. Thank you for watching, and yeah, good day to everyone. Thank you.